I'm Jeremy Fromm with Mercury Security, and welcome back to the Mercury Minute. I recently had the absolute pleasure to sit down with Skip Lochte of Lifesafety Power. We had a great discussion about best practices. We walked through the design that we discussed from last week. We talked about their ProWire solution, the different tools they offer with the wizard and the configurator. We dove into their PoE solutions. We talked a little bit about the future. Let's listen in. Skip, thanks for joining. I want to jump right in. Tell us about Lifesafety Power. What makes you different in the industry? What makes you special, and why do customers love you?
Well, first of all, Jeremy, thank you so much for having LSP be a part of the Mercury Minute. We're super excited to be here. Really excited to be able to talk about what LSP is doing and what makes a difference. And I think when I boil down everything, the word that comes to mind is efficiencies. And I really think that's what I evangelize, is bringing efficiencies. I think we all understand that the biggest barrier to the security industry is the accessibility of labor. My products can make the installation a little bit less laborious or eliminate a truck roll. I think I've done good for the industry.
Do you get pushback if you're making it easier for the integrator and they need less resources? Do they shy away, or do they not like to use the product because they like to do all their own wiring, or do they accept you with open arms?
It's funny, we first introduced our ProWire program because of an end user, a large global end user, asked us to do it. And when we first agreed to do it exclusively for them, it was very successful. It provided a standardized deployment globally for that customer, so every panel looked the exact same way, every label was the exact same. When we realized that the appetite was there for the market, we thought that there would be major pushback. People saying, you know what, we wire up panels better than you, or we wire up a panel a certain way. But the reality is, even if you look at the best integrators in any given market, whether it's a panel shop person or it's a project manager or tech 3-level person wiring up those panels, the service technicians will know when they open that panel. This is the Jim panel, this is the Sarah panel, this is the Steve panel, and they might all functionally be wired up correctly, but the way the wires are run, the color coding of the wires, what have you, it is not uniform and it's not standardized. So I think we first saw an early adoption of those enterprise integrators, right? They were quick adopters of this because they said, you know what, complete uniformity makes servicing this over the 15 years that panels can be hanging on the wall much more efficient. Well, now as news is spread and more people have adopted the ProWire technology, we're seeing that even get down to the local integrators that might only work within a region. Labor is very expensive, so our ability to make wiring harnesses at scale drives the cost of that project down. If I can eliminate one service call over the 15 years that thing's hanging on the panel, it just paid for itself.
So yeah, you have the efficiency component, but there's a big push towards intelligence and being smarter with power. And that's different, I think, what we've seen in the past where it's just basic power. Can you tell me what you do on the intelligence side and what data or information you can get from your enclosures and power supplies?
We're able to allow you to do things like monitor the load on the batteries actively at all times and make sure it's compliant with the company's specifications. We're able to allow you to remotely cycle power to a board, bring that back up and make sure the board's working fine, or a card reader, any attached device really. And we're also able to monitor locks, which is really a critical value add. Think about, if you will, I like to use the scenario of a magnetic lock. I know the industry says no magnetic locks, but it's kind of something that's forced, right? There are applications where you have to use a magnetic lock. And it's easy to highlight with the magnetic lock. If you think about a 1,200-pound magnetic lock, what the customer sees is they see a big metal chunk hanging from their door, and they probably don't like the aesthetics of it, but it's there. And there's 2 coils within that magnetic lock, each that have 600 pounds of holding force that it's responsible for. What we see in a 1,200-pound magnetic lock is we see 25.2 input volts. We see roughly 230, 250 milliamps, somewhere in that range, and about 6 watts. That's how we see LSP sees a lock, and how you would see it within our software. If one of those 2 coils fails, the lock still works, right? The holding force is now 600 pounds versus 1,200 pounds. So if there's a linebacker, they're probably getting through that door. But if a homeless guy tugs on it looking for a place to sleep, the door is still functionally locked. When that happens, when one of those 2 coils fails, we know that within a 72-hour period, at a maximum, that second coil is going to fail. So what we see in their software is we see that same 25.2 input volts, we're going to see the milliamps decrease. That's going to go down to about 170, 180, depending on the manufacturer. And those watts spike. So now those watts are going to increase to 9 or 10. So we see that voltage irregularity in the software and we initiate alarm. Now that alarm is going to integrate into most of the leading access control solutions, whether they reside on Mercury hardware or others. So now we're able to recognize that there's a problem. One, we can cycle power to that lock. If that corrects the lock's power, if the lock returns to normal, we just save the customer $500 or $600 on that lock, plus the associated service call, which could be over $1,000. If it doesn't restore to normativity, now we know the lock's in a state of failure. So now the integrator calls and say, your lock is in a state of failure. We know it's going to fail within 72 hours. Would you like us to come replace the lock? Now think about the inverse. That lock fails. You're relying on somebody internally recognizing that somebody walked through that door that should not have access and cares enough to report it. Right?
Yeah, because let's say I'm a student at a school and the door's open. I'm probably not going to report that. I'm just going to say, oh, cool, the door's open. I don't have to use my badge. So I just go in and nobody gets notified that this happens until somebody that shouldn't be there causes a problem and somebody gets notified.
That's right.
You're proactive on your monitoring. You're providing intelligence in terms of what's there so a tech isn't showing up with the wrong parts. In the end, that saves customer money.
If I can eliminate one service call over the 15 years that thing's going to hang on the wall, what's the ROI is pretty immediate.
It's pretty clear one incident, you pay for that incident by having a solution like this. The past few weeks of the Mercury Minute, I have talked about design of Mercury-based solutions. In the last episode, I had this mixed environment where it was an office building that had 23 doors. There was an MDF, a data closet. There was a remote guard shack with a gate. I'm curious, how would you design that from an LSP standpoint? Maybe we start at the MDF and there were 12 doors wiring back to the MDF. So I had a single MP1502 and 5 MR52-S3s. How do you design that on the LSP side, and how do you ensure that you have enough space? What are some best practices there?
We have a various amount of enclosure sizes that would support a 12-door application. Their smallest being the E4 enclosure with a Mercury backplate, and also a Mercury door plate would be required for that. We could do 12 doors in that configuration. The E6 enclosure, we could do 12 doors with that, again, with both a backplate and a door plate. Or the E8 M2 would fit 8 Mercury boards on the backplate. My personal preference, and I find the preference of people that I talk to, is always to keep those MR52 boards or the MP1502 board on the backplate. Door plates are great for IO boards, they're great for muxes, things of that nature, but there's no functional way to manage the cable from the backplate to the door plate. So just by nature of opening that door on a routine basis is causing unwanted tension on that cable, which will likely cause a ground fault. That's my personal opinion. We have a lot of customers that do it and they say, we agree, but we can't lease wall space in an IDF, right? So we wouldn't minimize that.
Okay,
Absolutely.
So we pick our enclosure size. We pick that we probably always want to use dual voltage and have 12 and 24 in the enclosure. Do you agree with that?
I do, and I'll tell you, we have a product wizard and a configuration tool on our website. The product wizard is answer 5 questions, and it will literally tell you what you want. It will say, is this, a Mercury software house, Gallagher, whatever install, you pick that out. Do you want wall mount or rack mount? How many doors do you want? And then dual voltage or single voltage, and then the enclosure style, and it will build out the most likely part numbers with the most popular version of that SKU at the top, right? And then from there, you can go in the configuration tool and manipulate a little bit more, customize it. So what we see is a lot of people that are new to LSP, or maybe it's a salesperson at a company that doesn't offer a sales engineer, they're the ones using the product wizard, where the consultant community, the engineering community, the larger integrators will definitely have engineers. They're using the configurator because they want to make sure everything's going to fit properly.
What does the distribution board do?
A distribution board is going to power your outputs, like a Mercury board or Rex device, maybe a siren that may be associated, right? Anything that needs just output power and no inputs. We have the D8 distribution board as well as our intelligent distributions, which would be the SD series distribution boards.
And the intelligent ones are how you're monitoring the amperage and voltage?
Yes, sir, that's correct, right? And be able to cycle power, cycle count, cycle power to connected devices. So that's all through our intelligence side. I'm a camera guy by nature, a long time at Pelco. So I consider our non-managed analog, as I like to say, well, it's an analog power supply, right? So the D8 is that analog version, and the C4, C8 are analog door boards. And then when you move into the managed world, we have the SD board, smart distribution, 4 outputs and 16 outputs, and managed the M8 board, which is our managed input output board. So that's the intelligent version of the C8. What we had found was a lot of our customers especially Mercury customers, were using the M8 board to power their Mercury boards because they wanted the availability to cycle power to an individual MR52 board as opposed to taking down all 16 doors. They just wanted to take down 2 doors. So our enterprise customers are really asking for that. So we developed the SD16. The SD16 has 16 dedicated outputs at 85% of the cost of a single M8. If you looked at a 16-door application with 8 Mercury boards, you would have 2 M8 boards for your 16 locks, and then you'd have another M8 board just to power the Mercury boards, and then you might have a D8 to power your Rex devices. So now I can give you that one SD16 for less money, and you can even monitor and cycle power to the Rex devices, sirens, anything that's connected.
Yeah, and that cycle power thing, I've heard that's become very useful for a lot of end users. There's an end user here in Florida that I know they have a ton of remote locations and it takes hours to get there. And sometimes either their controllers may lock up or they may have a reader issue that they need to power cycle a reader. And for them to do that in the past, they would need to send somebody to this remote location, do the power cycle, hope that that fixes it, and then continue their troubleshooting. And now since putting in the managed devices, they can from their office say power cycle that board that has that reader connected to it, and then they're able to continue with their troubleshooting and save a ton of time and money. On the remote location in my scenario, the guard shack, I'm putting a MP1501 in there and I'm powering that with PoE+. Do you have an enclosure that is small that would fit a single 1501? How would you design something like that?
We just launched a NEMA 4 enclosure at ISC West in the form factor of an E1, which will give you that exact functionality, right? You'd be able to put a single Mercury board in the E1. We do have a series of power supplies called the BX series. There's a 50 watt and a 75 watt power supply version of that. And then you would add any attached devices, whether you needed a C4 board if you wanted to do it analog, so to speak, or you can even use an M8 and have that component and do the manage. The BX50 is 60 watts PoE power, and the BX75 is 90 watts PoE power. So we offer a mid-span injector. And what's unique about the mid-span injector, and I'd love to talk about other applications for it that I think are really cool, but it has a UL listed fire alarm interface on the back of the mid-span injector. We call that single point fire. So if you picture an Ethernet cable with 8 cables, right? You're gonna have 2 for power when it's under 60 watts, you're gonna have 4 for data, and you're gonna have 2 that are empty. So on those 2 empty wires within that Ethernet cable, we're gonna send that fire alarm drop notification out to that BX50 and drop power upon fire alarm. A little bit less important on the gate scenario because you're already outside.
But for a remote door that needs to follow fire protocols, that's a great option.
So if you use the 75, we're going to need 4 wires for power because you need the full 90 watts. So you lose that functionality and you would have to run an 18 too. So we would leverage that technology to power that power supply and push the voltage down. So I'd like to talk about the scenario where you only have 10 doors, right? We can either do that in a smaller enclosure with the Mercury backplate, as we talked about with the 12-door application, or we could potentially use their bitstream device, right? It's a mid-span injector PoE. We also have a switch version of it, but realistically, it's getting that 90 watts PoE plus out to the field at a maximum. They have these locks, and I know Sargent makes one called the IN220, but it's a fully integrated lock. The card reader's in place, the lock, the transfer hinge, very clean, professional look.
It's like an all-in-one lock powered with PoE.
Exactly, right? And they're drawing like 6 watts. And the cost of renting this lock a year is like $3 or $4 versus $60 for a typical access control lock. So we can actually save a lot of money on the installation. I actually lose money because my switch is less expensive than my enclosure, so I probably shouldn't talk about it. But I think it's a great way for interior protection. So we go back to this switch. It's a managed switch by LSP. So we're able to monitor the AC input voltage like we are in an enclosure and alarm off voltage irregularities. We're able to monitor the ports and look for any port irregularity. DC current is very consistent, so you set the tolerances. You can cycle power to any port on it. You can have prioritization. Maybe the CEO's office, that door and that camera associated with the CEO's office, maybe that's more important than the break room camera. So you can say, you know what, port 1 and 2 are priorities. Port 6 is the break room camera. You know what, if it goes down, it goes down. We'll accept that to keep ports up and running. So really nice expanded functionality. As I mentioned, you also have that fire alarm drop available to you, so you're able to drop remotely. And I think that's really when I talk to the consultant community, and that's who I support in my day-to-day job as the consultant community. They're looking for environmentally friendly ways to secure buildings, and everybody's really excited about the flexibility these solutions offer.
Yeah, LEED certifications are becoming more and more important every single day that we talk with customers and new builds and retrofits. So that's a nice option. One thing that I love about that, and it probably doesn't help Mercury either because we're selling less Mercury controllers,
right,
but giving the customer choice has always been Mercury's mission. Being able to design a building and having power solutions, intelligent power solutions, where something's going into a data closet or an MDF and having a Mercury backplane there, or going out to a guard shack and maybe having a small enclosure that's NEMA certified out there, or having PoE++ where you can do PoE locks, and allowing the customer to pick and choose the best application for their environment. And the best part is they can mix and match these, so it doesn't have to be all or one. So put the best device at the location for that opening, and you allow them to do that with your different options. So it's really nice. So maybe just a couple of best practices. I think we hit on a bunch of these with having the network module and the intelligence to power cycle devices, using dual voltage 12 and 24 inside of an enclosure, some of the PoE+ options that you talked about. Any other best practices? If you were to give a list of maybe like 3 or 4 things, what would they be for a customer?
I think first and foremost, we are a network managed power supply at our heart. So when you go with a network managed power supply, I think the most important thing you need to do or be aware of is firmware updates and make sure that's done on a timely manner. But we don't ever want to leave ourselves vulnerable to cybersecurity attacks. We do independent pen testing on our products twice a year to make sure they're certified. And whether it's our large corporate Fortune 100 companies or the DoD, we have third-party pen testing on a pretty regular basis. But if you're not updating your firmware on a regular basis, all that's for naught. I think more than anything, people aren't used to having intelligent power, but when you have an intelligent device, firmware is vitally important.
I'll say this about firmware updates, because you're speaking my love language. There is a convergence of IT and OT, and we need to do better as an industry to update firmware on our edge devices, because there are so many threats out there. Without doing that, why put in the intelligence if we're just going to compromise our system? I'm hopeful that the industry will catch on and we'll start updating firmware on readers and on controllers and on power supplies and on cameras, and it becomes a general practice, just like it is in IT. And hopefully access control doesn't make the news as the entry point for the next cyber breach.
The other best practice is a little known product release that LSP released at ISC West. We have cyber threats, and then we also have local threats. Think about how many technicians are in this industry that have a key to an access control power supply. Well, ASABWay makes they call it the KS210. It's an integrated lock, integrated with the card reader as well as a mechanical key. So we're starting to launch. We have it available on our E2, E4, and E6 enclosure right now. Now that technician generally has a credential from the issuing agency. They're able to present that credential. There's a record that John Smith has entered that enclosure. We have the trackability of who entered that enclosure. That's a new thing that isn't really recognized in the industry yet, but something I hope really catches on.
Extending access control just from your traditional door to the devices that we're using to control those doors is pretty critical, and the KS210 lock, that enables it. From a Mercury standpoint, that will be available soon. We showed it at ISC West, but we're putting some final touches on some of the engineering, and we need to release it to our partners so they can do that integration as well. So that will be coming soon. It's not quite available yet, but it will be, and my opinion is that should go on every enclosure, and it can be used for your data center racks as well.
We talked about ProWire before, and I just think it's worth rehashing.
It looks nice every single time in a consistent way, in a standard way. So it doesn't matter who's installing at that point. You get the same wiring diagram, you get the same standard, the same everything every time. When I was on the OEM side selling access control systems, I always recommended that the integrators or the value-added resellers that I worked with, that they heavily look at ProWire. It saves them time. It allows them to focus on the critical things to make a system function versus spending time in the field field, wiring controllers. What do you give to consultants to help them with their Division 28 specs or specifying solutions? What are some tools that they would typically use? Is it the wizard and the configurator? Is it something else?
I think the configurator at the consultant level is its greatest tool because they want to see that visualization. You can literally drag a Lux into it. You can literally drag an MR52. And so they want the assurance that what they're designing is correct. I mean, every consultant's a little bit different. Some are very granular and they're doing incredibly detailed riser diagrams, as you know. And other ones will just give a performance spec and say it's on the integrator to figure out if you want to put this in an E6 or an E8 or an E12 or, rack mounted. That's up to you. We're just telling you this is the performance spec. But I think at the end of the day, our configuration tool is the greatest tool that we have to offer. We do have behind the wall things that we can assist them with, like CAD files and stuff like that. In our performance specification, we're just about to launch a new network board, the NLC, which will be coming down to GSX. Very exciting. What's coming with that will be on Google's programming language, not C++, so it allows a lot more flexibility and growth and cybersecurity. So we're updating our specs right now to allow for that.
If there's consultants listening into this, reach out to Skip and make sure you're on the list to get those updated specs.
Please, absolutely.
Final thoughts. What did we miss? What's your final takeaway?
Well, the one thing I'd like to share about our tools in general, whether it's the product wizard, the configuration guide, or even one of their BDMs or technical support people as a sales resource. Everything is based off generalization. We can say that most locks are 250 milliamps and most Mercury boards are 500 milliamps. And we base our load calculations off that, off generalizations. Just like it's your responsibility or the responsibility of the bidder or procurer to do the battery counts, it's also the load counts. We'll have incidents from time to time where a customer may have a siren that has a normally high inrush current, and that causes the system to go into alarm or fault. And you'll see this happen from time to time. We need to understand exactly what your load is on the board. And we have tools on our website to help you calculate that load, but that's the due diligence that needs to happen. I always say, if it's a greenfield location and it's not a very typical design, just power up. Just go to the next size power supply and make sure that you're covered. Because when you fail and you're on the phone with their technical support team and they're very good and you're troubleshooting, and now you need to order another part and that's another trip, another day away. If you need to spend a couple extra bucks to make sure you're safe, I encourage people to do that. If you're not willing to do the granular work it takes to do the load counts, I would tell you just level up just for that insurance. But everything that we produce is generalizations, and I don't think people fully realize that.
Key takeaway, make sure you're doing your calculations properly. Otherwise, you might not have enough juice. Thank you. Really appreciate the time.
Great. Thank you so much. Great being a part of this.
Skip, thank you so much for spending the time with us. That was really beneficial and helpful. Tune in next Monday morning, 11 a.m. Eastern Time, where we're going to kick off our cyber series. And we're going to talk about end-to-end encryption. That's the Mercury Minute. Stay open and stay secure, my friends. See y'all next time.